Hello everyone. Alright, so this is another example, right, about the graph, domain, and range of an exponential function. Okay, so in the previous video, I showed you guys how to deal with this type of problem, right? But in the previous video, we did not change the asymptote. So here is another example where we are going to play a little bit with the asymptote. Okay, so here it is. So this is the equation of the function. Okay, here's the equation. We are going to draw a table, right? Find the points that we're going to use to plot in. So this is my x, my y. So as I said before, when we choose the x, we should choose it smartly, right? So when x, let's say when x is equal to 0, anything to the power of 0 gives us 1, right? So 1 plus 3, we have 4. Okay, and the next value I'm gonna choose would be -1. Okay, -1, and you see why. All right, so 1 over 4 to the power of -1 is equal to, okay, so x to the power of -1 is equal to 1 over x, right? When we put the 1 over x to the power of 1, right? When we put this 1 over, that will take care of the minus, the negative exponent, and this 1 just goes to this 1. Okay, let's say if I have x to the power of -3, then I will have 1 over x to the power of 3. Okay, by putting 1 over, we took care of the negative. This 3 just goes down there. Okay, so 1 over 4 to the power of -1, same thing, 1 over 4, right, to the power of 1, which I'm not going to write. So 1 divided by 1 over 4, this is just equal to 4. That's why I picked -1. Okay, so when x is equal to -1, my y is 4, right? Oh, sorry. When x is equal to -1, so when x is equal to -1, this part would be 4, right? This part would be 4. 4 plus 3, we have 7. Okay, so now we have 2 points. This is our first point, 0, 4. Our second point, -1, 7. Okay, so we can put those 2 points in. Alright, so now we have 2 points already. Our next step is to find the asymptote. For this type of questions, the asymptote the asymptote will not be on the x-axis anymore. Okay, unlike the previous question where the asymptote is basically the x-axis. For this type of question, we are not. For this type of equation, we are not going to have the asymptote on the x-axis. Okay, why? Because of this. Because of this plus 3. Okay, we learned from last semester that when we add a positive number to the y, it will go up. When we add a negative number to the y, it will go down. Right? So basically, let's compare. Okay, basically this means that the asymptote is either going to go up or down depending on the number behind it. Okay, so for now, for us to figure out where the asymptote is, let's look at these two graphs. Okay, we can see that this is the original function. This is the equation given to us, and it looks very similar to this function, right? The only difference is here, plus 3. Okay, so as you can see here, this is a graph for that. Okay, so when x is equal to 0, I have 1. Right, x equals 0, I have 1. When x is equal to -1, I have 4. Right, for this graph, x, y, when x is 0, so anything to the power of 0, I have 1. and when x is -1, I have 4. Right, so -1, 0, 0, 1, -1, 4. Okay, so this is the graph for your fx, right? For fx, f. Okay, so we're going to add a 3 to this, right? So instead of 0, 1, now we're going to add a 3. Right, add a 3. So if you look at this table and the table that we just calculated, they are exactly the same. Correct? 0, 4, -1, 7. Right? So this is what this 3 does. It moved this point up by 3 units. Right, so now when x is equal to 0, originally it's 1, now y becomes 4. Good. This will go up by 3 units. Right, so at this point, originally when x is equal to -1, y is equal to 4, now it's going to become 7. Right, so now the whole thing has been moved up. Therefore, the whole thing has been moved up by 3 units. Therefore, your asymptote must also follow. The asymptote originally it's here. Let me choose red. Okay. Originally it's here, right? Originally the asymptote is on the x-axis, right? Y is equal to 0. Now it's also been moved up by 3 units. Okay, so over here this is your y is equal to 0. So now the equation is y is equal to 3. Right. So now instead of having the asymptote at y is on the x-axis, now the asymptote is at y is equal to 3. Okay, so how? So now we have 2 points. The asymptote. Click on the line. Click on the line, and I think Alex would do this for you. Right? Alex would draw this line for you. All right. So we're almost done. The last part is to find out what is the domain and what's the range. Okay. So if you look at the graph, x domain is basically where can your x be, right? So if you look at the graph, if you look at the graph, x can be again anywhere, right? X can be anywhere from you can go as small as you want or as big as you want, right? So x, the domain, is basically -infinity to infinity, right? As small as you want or as big as you want. Okay, what about the range? What about range? Okay, so for the range, remember last time I told you guys that when we look at the range, we need to look at the asymptote, right? There's a relationship between the range and the asymptote. So, as you can see here, this line, this blue line, it can keep on going, right? It can keep on going up, 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 keep on going up. So, there's no really a boundary, right? There's no limit to where the y-axis can go, right? So, which means our range has infinity range upper boundary, right? This is our upper boundary, which is it can go as big as it wants, right? As it can go all the way up if it wants. However, our lower boundary would be the lower boundary for the range would be where your asymptote is at, which is 3, right? Which is 3. So you put a 3 here, right? Your y cannot go below 3, right? Because your asymptote is right there. Your y cannot be 3 because your asymptote is here. your y can be something like 3.00001 or even 3.0000001, right? It can be very, very close to 3, but not 3. Okay, so this is your lower boundary, which is basically your asymptote, and this is your upper boundary for your range. Alright, so this is another example where it's the same topic, okay, the graph, domain, and range of an exponential function, but for this equation we need to move the asymptote a little bit, which also affects your answer for the range. Okay, so there is a relationship between let me just put it down. So range, asymptote, and range. Okay, there is a direct relationship between them. Okay. Whereas the domain, I think for this topic, every time it's just gonna be negative infinity to infinity. Okay, but for your range, you need to keep an eye on where your asymptote is at. Okay. All right, guys. Good luck, and let me know if you need help. All right. See you guys in the next video.